Hi everybody, welcome to my talk about how to close the developer experience gap of your container platforms. My name is Timo Salm and I'm a pre-sales specialist for developer experience at VMware with a main focus on our internal developer platform products like Tensor Application Platform, Azure Spring Apps Enterprise, which we jointly built together with Microsoft, and also our commercial Spring products, because as you maybe know, VMware is the vendor of Spring, so we have nearly all of the paid open source committers. What I will talk about today is really what the problem is, so the developer experience gap of container platforms. I will introduce that. And then I will show you some of the open source technology that help you or your organization to actually provide an experience for developers where they don't have to care about how the applications and where the applications run. So before we dig into the technology, let's have a look at why we actually need those technologies or a container platform, etc. And in the end, it's like if we have a look at the traditional software development, it was really like the illustration you can see here on the slide. So the developers, they usually worked for several months or even years at one iteration of software. In the meantime, the operators had plenty of time to, in a way, provide all the infrastructure that's required, so virtual machine, the middleware like WebSphere, a database like Oracle. And then after the time, the software developers packaged together the application, created an operational manual, the SQL scripts, and just more or less threw that to the operators that were then responsible for deploying the application, doing day 2, and also supporting the application. The problem with that approach was that actually because of the long release cycles, there was a huge risk in whether the application actually works and also whether the users will accept it. And also a huge risk that other companies, for example, already have a solution available until the one of the company actually is available. And therefore, a lot of organizations already moved towards agile methodologies to actually implement software, to have shorter release cycles, be early at the market, and also then with that reduce the risk. In addition to those agile methodologies, so in the past it was like that you had a huge team of people working on a complex application, and to also be faster and also more independent. Nowadays, a lot of big applications are built as so-called microservices, where smaller teams are actually working on specific microservices, and with that they can, for example, also be independently deployed. And those new architectures, they're a lot more complex not only to build, because you have to think about latency, etc. It's also like that they are a lot more complex to operate. And because of that, there's really a need for a so-called DevOps culture. So DevOps is not like another silo in addition to the developer and operation silo. It's a culture. And at the end, it's really focused on the collaboration between developers and operators. And for sure, and that's really what you should do, you can automate a lot of that collaboration via self-service capabilities, and then for sure also the path to production. Another requirement for these modern applications is really that you also have rapid application deployment and provisioning capabilities. And as we know, for the automation, we have CI/CD, so that automated path to production. And then containers really help you to spin up infrastructure really fast. And for Kubernetes, they only solve part of the problem. You also need, for example, then to manage the operating system, things like high availability, etc. And for that, we have container orchestrations like, for example, Kubernetes. Also, as you maybe know, nowadays it's not like in the picture on the left. So the developers, they work on an iteration, then they threw the software to the operators. They were responsible for the support, also bug fixing, and they were assigned to another project. Nowadays, it's like the development teams should have or should be responsible for the full life cycle of an application, which doesn't mean that they need actually to deploy the application or they need access to Kubernetes, whatever. At the end, they just need the tools that support them to get all the information they need. In this case, for example, a really good observability tool so that they can really see whether the application behaves like it should be. If we have a closer look at Kubernetes as a container orchestration platform, it's like Kubernetes is nowadays the infrastructure, the infrastructure abstraction standard for modern infrastructure. And the reason is that it's really available everywhere nowadays. And this really enables a hybrid cloud model so that you can run your applications in the same container, etc., on premises and also in the cloud if you want to, for example, scale or have specific demand. As already discussed, it enables shorter development cycles and also other things like more flexibility, for example, for the developers regarding the step, because the stack, because in the past usually it was like the organizations had one or two supported stacks, like for example, as I mentioned, okay, a VM with vSphere and a specific JVM version and Oracle database, and nowadays with containers, developers have a lot more flexibility regarding those stacks. Kubernetes itself, a lot of organizations is deployed and there are clusters available, and because there's a lot of misunderstanding about is that responsibility. It's like at some organizations, it's just, okay, here's a Kubernetes cluster, do whatever you want with it. So like it also is with a lot of organizations with public clouds, where it's like, okay, here's a credit card and now do whatever you do. You want to do. At the end, it's like software developers, in most of the cases, they don't have the expertise to actually do that. And especially at scale, that's a huge problem. Kubernetes itself, even if it provides an abstraction, which is really low, at the end, it's a tool to build a platform. It's not a platform. So the abstraction is a way too low for software development, especially at scale. So if you don't have just one team and they more or less operate the software in a you build it, you run it mode, actually at scale, you have to consolidate to secure your applications and also to, in a way, not waste too much money and time. And Kubernetes is a tool for that. And to build a platform, because it only provides base functionality, there's a really huge ecosystem around it. You can imagine for all the capabilities you need in your platform, it's really hard to pick the right solution, so there's a lot of effort, and then you still have to update, maintain them, for example, in your IT department. And also always have a look whether there are new or better solutions available that fulfill your requirements better. So at the end, it's like, as already said, the abstraction for developers that Kubernetes provides is a way too low, because it's like you have to really need an expertise in Kubernetes, in container concepts, and other things. And most of the developers, so that's not their core business. They should focus on writing business code. And that's, at the end, the only way the business gets value out of them. So any second developers are spending on infrastructure, containers, whatever, is wasted time for the business. And as that, really, especially if in huge organizations, you can or will waste a lot of time if developers are responsible, for example, also for the deployment. But it's not only about time, it's a lot about security, because if you don't have the expertise in how to secure your applications running in containers, that's really bad for the business. And we have a look. So what do developers usually, or what do they have to do to run application in Kubernetes? At the end, it's not much to get it running, but because you just have to build a container image. If I want to have a container image for a Spring Boot application, I just Google it. It's 4 lines of code. I build my container, push it to a registry. Then also via interactive commands, I can create a deployment and then maybe a service. For an ingress, I maybe have to configure a little bit more, and my Kubernetes cluster has to be configured for an ingress controller. But the end, it's like it's not much to do, and my application runs. But as you can see on the right of the slide, there's a lot more things to do to really run it in production. For example, also defining the security context, so which privileges are really required to run the application. To reduce the attack vectors, also things like scaling, as I said already, exposing the application maybe via TLS, etc. So there's a lot of more things to do than just actually getting working on Kubernetes. And so as I said, why is it important? At the end, it's like any second developer spent on infrastructure is more or less missed revenue for the business, because in this time they can, for example, work on innovations, trying new stuff out, or just add new functionality that the customers are asking for, or at the end maybe use the time and write some tests for the application, which are probably, or in most of the cases, also something that's missed. And I would say the ambassador or ex-ambassador of Kubernetes just said here in March how in the future the experience should or will look like. At the end, it's like developers, as in the picture of traditional software development that I showed, they just write product code, a little bit of configuration, and the rest will be done by the platform. So this is his vision. At the end, it's like there are solutions available that are already doing that, like, for example, Cloud Foundry, etc. But at the end, this is also, in a way, his vision for the Kubernetes ecosystem. At the end, it will take some more years to get there, because, as I said, it's also not easy to build such a platform. So how should a platform look like? So most of the Kubernetes platforms I see at our customers, they are like on the left. So they have different abstraction based on the tools they're using on top of Kubernetes. But again, it's like you have to, in a way, make your application platform aware to run it on it. And an easy example is just if you are building Docker files, you're not on we call it an app-aware platform, where all the infrastructure specifics are in best case abstracted away. And this experience not only helps to make developers more productive, so an app-aware platform, it also helps with portability. Because, with that, it's really easy to bring it to another app-aware platform if you don't have to change anything in your software for that. In the next 40 minutes, I will show you some of the tools to get started building an app-aware platform. And for sure, there's a lot of more effort than involved to actually polish it and, for example, provide a self-service for developers, etc. But that's something a platform team in your organization should do, especially then also to consolidate and have all your developers in the organization running the applications on one platform to get all the benefits, like also security. And the first thing you usually do to run your application, I already talked about it a little bit, is you have to containerize it. I guess most of you that are already running applications on Kubernetes or another container runtime, they define a Docker file, as said, only 4 lines of code, and I have my container image, build this file and to a container, push it to a registry, and then probably there is some CD step that's maybe owned by some operators, or you build it, you run it, that's the mode you're doing it yourself via, in best case, automation. And as I said, so it's just like this, 4 lines of code, and my application is running. But if you have a closer look, it doesn't look like that's a really good Docker file. And this is the same with any of those aspects I will talk about today. And it's like to build a container with best practice in mind, a secure one, you need a lot of expertise to actually do that. We can see here, for example, they are still using OpenJDK 8. And so I have a software development background, did that for around 8 years. We only updated the base image if we wanted to use, and we were allowed to use some newer version of JDK to get some features. So how many of the developers care about new patch releases of a base image? Not a maturity, I'd say. And it's like, because defining the Docker file has to be in the hands of the developers because they know how to run the application, etc. It's a common problem that they, actually, if there's a CVE, have to patch it manually, because it's here you can see it's just a base image without a tag. So always, if you build it, there will be a new version probably as a base image is a bad practice. So it should be a digest, or if you don't want to define it with a digest, it should be like really the version with patch release that you want to use. And then for sure, on any update, any CVE, etc., someone, a developer, has to update the Docker image and trigger a rebuild. If you have a look at a more advanced container or Docker file for a container image, you can see there's a lot more things that you can do. So it starts with choosing the right JDK and JRE for your application or container image. Then you can see we are doing a multi-stage build here to, in a way, reduce the attack vectors, because we are only packaging all the files, etc., that we actually need to run the application. So also using a JRE instead of a JDK for the runtime. Then you can see we're using layer jar functionality, which means that in the container image later, the source code is on a different layer than the dependencies, for example, and the middleware, Tomcat, etc. And with that, if you update, so what's frequently updated is only the source or the business code. And that means that not only the container image building, so there's a caching mechanism, is a lot faster. It also means that it's smaller, because only those updated layers have to be stored on a disk, and also then pushing them to the registry is a lot faster, and also then pulling them on the Kubernetes side is a lot faster. So as you can see here, with this easy example, there's a lot of things you have to know to build a best practice Docker image, and therefore, I don't think all the developers have that expertise. So the question is, how can we improve that? And one of the solutions Heroku and Pivotal came up with is the Buildpacks. And what they do is actually they detect what kind of application it is, so also technology-wise. And based on that, then they, in a way, contribute to a Docker file all the requirements with best practices in mind. And in 2018, they created this new Buildpacks standard. It's called Cloud Native Buildpacks. It's available on Kubernetes and now also on Cloud Foundry. And what I said, so compared to those traditional Buildpacks, they're a lot faster, they are more modular, and really, you don't have to care about how your application will be actually translated into a container image or how that will be built, because all the best practices, also security-wise, are in those build packs. If we have a look, you can see, so buildpack.io is the website where all the, in a way, specification is defined. And then we also have open source build packs available for any major language with a Pacato build pack project here. You can also see, for example, I think you heard a lot about GraalVM. So we also have a build pack for GraalVM native images. And as that, you don't need a Docker file. It's just like, here's my source code, build a container image for me. So all that defining of the stuff is, in a way, abstracted away from you. To do that in your CI/CD pipeline or on your local computer, we have a CLI called pack. And as you can see, it's just like, okay, build me a container image with that tag. So then if you would push it, you can also directly push it, which I'm not doing here. The path, in this case, because the application is not in the same directory, and setting some environment variables like this here, okay, what's the JVM version? And that's it. So what then will be done, you can see this here in the log. So I executed it beforehand because it will take some time to also download those build packs if you do it the first time. And what it does is it's going through all the build packs that are in a way defined in a builder. And they have a detection step based on, for example, you can see the Maven build pack here. Oh, there's a POM XML in the source code. Now I know that this build pack is, in a way, can contribute something to the container image. And then there's different build packs that are detected. They will be run against the source code. And you can see this, for example, here with the JRE that will be used to build the actual application. So it will contribute that JRE. Then you can see, if we scroll a bit down, the Maven build pack that was detected builds our application to a jar file. So you can also for sure build your jar file yourself and just use that as an input. But in this case, it also builds our application because it knows how to build an application with Maven with a package command. But you can also define those things, so change that based on environment variables. So it's not like that everything is like fixed. You can also, there are configuration options via the environment variables. At the end, it's going through all the different build packs that contribute something. And then you have really this container image with best practices in mind. As said, in this case, it's not pushed to a registry, but you can also add at a flag, that it will directly push it to that registry. So at the end, it's like a nice CLI to build a container image out of any commonly used framework or a programming language. As we are here at a Java conference, some of you may have heard that with the Spring Boot 2.3, so some years ago, we also introduced Buildpack support for Spring Boot, which means that if you have a Spring Boot application with a higher number than version 2.3, which I hope that most of them are, you directly have this Buildpack support out of the box. And with Maven, you can see there is a Spring Boot build image command, where you can specify the image name you want to build or the tag, and that's it. So it will build your application via those build packs and package it as a container image for you. The same is also for sure available for Gradle. So if I have a look at Gradle, you can also see its boot build image. Same thing. You can also for sure configure the image name directly in the POM.xml or in the Gradle configuration if you want to have it fixed. But yeah, and it's like with that, you have all the benefits directly in your Spring Boot framework. So that's nice. Now we have a way to easily build container images. Developers don't have to care about the best practices, etc., that are just out of the box in these build packs. But yeah, we didn't solve one problem, and that is how do we update the stuff that's coming from the build packs and also the base image that is used. And for that, we created a project which we just some weeks ago contributed also to the CNCF. So that's a CNCF project, and also KPack now. We contributed it. What it does, it's running on Kubernetes using Buildpacks, Native Buildpacks. In addition, it's also like updating. It can update the base image automatically and also the build pack. So they are configured in a Kubernetes cluster. And then if, for example, a new base image is available and it will be updated, it's based on the image configuration it has. So how to build an image, we started with the tag and where's the source code. It will automatically rebuild a container image and push it to the registry. And with that, it's like, the base image updates at the end are in the hand of the operators in an automated way, which is really great because now developers don't have to care at all anymore about it. Otherwise, they would have to, if there's a new CVE, for example, rebuild the container image with a pack CLI or rerun the CI/CD pipeline. And as said, with that KPack, it's completely automated in Kubernetes native. To make it a little bit easier or user-friendly, there's also CLI to interact with KPack. It's called the KP CLI. And to more or less do the same, build an image and automatically push it to a configured registry, what we can do is just KPack image create. You can see I will give it a name, define where my source code is in my Git repository. It's also possible to do that from local, then it will be, so local computer, then it will be packaged in a container to then be fetched by KPack. I defined the tag and also an environment variable as with the pack CLI for the JVM version. And now it's created. At the end, for sure, it's just a custom resource in Kubernetes, and then there's a controller doing all the stuff for you. So if you have a look, kubectl exporter is a plugin that actually removes all that information we don't need, like the status, etc. Image.kpack.io. And what we can see in this CRD here is everything I specified, like the name, the environment variable, then also some additional stuff, and the source code here and the tag. And you can see that here is the builder. So that's really that component that actually configures which build packs and which versions are used, and also then the stack, so the base image, plus for sure also the detection order, because it could be that you have two different types of application source code in one repository, and then in a way there has to be a detection order to, for example, then build the Java application instead of packaging something together with a web server. And we can also have a look at it. So if we go to cluster builder, status default, so that's the one in my cluster, we can see here is the stack reference. So the base image, in this case, Ubuntu Jammy, and you can see all the build packs and really the modularity I talked about. So a lot for all the different types of build packs that are configured here by default in this environment. And then at the end, you can see the detection order, because even if they are so modular, it's like you have groups of build packs, like for example for Java or Java native image, and then in those there are all the different modular build packs defined that are used for it. If we have a closer look at our image, we can first list all the images in my namespace. We can see it's ready, and you can see that there is config, so that's the reason why it's built. We can also re-trigger a build, but as said, that could be also the fact that there's a new base image available, and it will be re-trigger also then another build to update that base image. And for sure, we can also have a look at the builds itself. So with the build list command, we can see the build succeeded, also the tag words available. And with the build logs command, we can also then have a look at the logs. And as expected, more or less, it's the same output then from the pack CLI, because it's doing the same stuff here. So that's nice. So now we have our container image built in the Kubernetes cluster. What's next? So usually the next thing is, OK, I have a container image, let's run it. And for sure, I could just easily, also via interactive commands, create a deployment, create a service, etc., an ingress maybe. But yeah, maybe there's something to abstract this stuff a little bit away. And yeah, for that, there's a solution called Knative. Knative is more or less a serverless runtime on top of Kubernetes, so providing a higher abstraction, but also a lot of capabilities like auto-scaling, scale to zero, blue-green deployment, canary deployment capabilities. Before we talk really about or have a look at what this serverless runtime does, let's first define what serverless actually is. At the end, it's like you can group it into two areas. The first one is backend as a service. It's really replacing server-side self-managed components with off-the-shelf services. So one example is, instead of building your own authorization server, etc., that you just use a SaaS service like Okta or Auth0. The other group is a function as a service, which is actually a new way of building server-side software as smaller independent functions. And the key at both is at the end that you have a higher abstraction. You don't have to care about the management of the stuff. So as with any SaaS service, which actually is really then focused on business value. So it doesn't make sense to manage everything yourself when you're not able to get a business value out of it. Knative actually has 3 different components. So as that the serverless runtime is actually one of those. It's called Knative Serving. This is what I want to show you also today. Then we have eventing, which is really focused on providing the infrastructure in a way for event-driven architecture. For example, sources for events, then also abstracting away the brokers or RabbitMQ, etc., to actually consume those events, and then also things, so definitions of how to, in a way, save or those events. The newest member is functions, and that's really a way of, or the idea is to provide developers all the tools to actually build and create functions, and then also run them on a serverless runtime, like, for example, Knative. At the end, it's like what it provides is more or less like AWS Lambda, but you can run it everywhere because Kubernetes is available everywhere. And to show you how that works, what we do here is more or less the same than with KPack. So we will use a CLI for that because it's more user-friendly. The CLI is called KN CLI. And with the KN service create command, you can see for sure there's a lot of more configuration available. You can more or less configure anything like you would do it in a deployment. So how the pod runs, plus additional things like traffic splitting, etc. But that's the most basic command that really shows the value of the solution. So it's just like and service create, the name for the service, and then we have our image that we want to deploy. And you can see after some seconds, it will create anything for you that you at the end have a reachable URL, which is in this case, because Knative is configured like that, also TLS enabled. So after some seconds, you actually have a URL and can access the application from the outside if you configure it like that. So as you can see, it's just a basic demo application from me. It's called inclusion. The idea is that it's using an in-memory database, which you can see here. And maybe if we move forward a little bit, we want to have a real baking service, a real database, and then we can see some effects here in this sample application. So so this was really the basic functionality of Knative serving, but there's more as that. So for example, Knative has auto-scaling, etc. Let's first have a look at also the CRD, that you get an idea of what's actually configured. So service is the name of this resource. So it's also a service as that. Serving service, so not the service that you use to, in a way, expose your application. And what it has is really like in the spec is a template, which is as that like the definition of a pod in a deployment. So it's really the same, but it has additional configurations, like, for example, here the traffic. In this case, every traffic is going to the latest revision, but you could do things like canary deployment or blue-green deployment, where you say, okay, 50% to this revision, 50% to the other revision. We can also have a look what the Knative service, because that's the only object I created with the command, actually does via the kubectl3 command, which is also a plugin. So actually it shows all the resources that are created by one resource with a Kubernetes part of label, so based on that. And you can see it has a configuration, which is the actual current configuration. And then those revisions, which are previous configurations. You can see currently we only have one revision, and this revision created a deployment and a replica set. So the deployment created a replica set. Then we have a pod autoscaler, which is defined based on specific metrics. We have a route, which defines under which URL the application is actually available and which of the revisions. So all of this stuff is created for us with just one CRD at the end. One feature I want to show you, which is really nice also about Knative, is the auto-scaling. So if you have a look, we can see currently in this namespace there's only one pod, and that's the pod that was used to build the container image. But yeah, as you remember, I actually already called my application and had a look at it. Why is there no pod? At the end, it's like by default, scale to 0 is configured. So we have not, we have none of the pods containers running until there is a demand. The problem with that is for sure it usually takes some time to start an application. But as we know, there are solutions for that available to improve that a lot. So my sample application, it starts in around 3 or 4 seconds. If I would build it with, for example, as a VM native image, it would be like 300 milliseconds, something like that, which would be enough to not run in a timeout. But for now, it's not optimized. Let's run a load test against the cluster. I use the Hey CLI for that. It will just send, as you can see here with the -c, 1,000 parallel requests for 60 seconds. To my URL, and then if you go to the watch, we can see that Knative is going in a panic mode because it sees, oh, there are a lot of requests coming, and none of the pods is handling them because they are starting. So it's creating a lot of pods now, but at the end, it's like if you have pre-provisioned some of your instances, it's not like that. So it behaves as normal, and you can also, in a way, for sure optimize that. You can see, so those were around 9,500 requests I sent here, and they were handled by all those pods that were auto-created. And I said all the stuff you can fine-tune, so it's not like that it's like, okay, those are defaults, we have to use that. And one of those options is, for example, also define a min and max scale. This can be done also then in the resource. And yeah, we can also do it via the CLI via the update command. So we will just add an annotation with auto-scaling min scale 2. Then it will create a new revision, which you'll see in a second, with a new configuration, and then we have the 2 instances running. Let's see. Maybe take some second until it's available. But we can already have a look here. Just go to this window and do a KN revision list. So we can see there are now 2 revisions. So the second one, where 100% traffic is going to the second one, so the one with that min scale. Okay, perfect. And if we go to the application another time, you can see what the idea of the application is. It's an in-memory database. So every instance that is running by random has a different emoji here. And if I refresh, for sure, I will be directed to different instances that are running. Okay, so that's it for Knative for now. So now we have a way to, in a way, abstract away or have a high abstraction for deploying application, for building container image. What's next? And in the end, something I would say especially the modern applications, even more than those traditional ones, because they are, in best of case, all of them or most of them are stateless, which means they are not saving anything that should be persisted on a local disk. Instead of that, they're using databases and a lot of other infrastructure like caching, etc. So we need a way to, in a way, provision our baking services. And for sure, there's a lot of tools available to automate this stuff, like, for example, Terraform, etc. But there's also something, oh, I missed something, but that's not a problem, so I will show that in a second. There's also something available to, in a way, let's just jump here, to, in a way, make this Kubernetes native, and that's Crossplane. So Crossplane is a project that more or less does the same like Terraform, so automation of creation of resources that are in the cluster and outside the cluster. The difference is that it's actually run in Kubernetes and using Kubernetes to save the state. In contrast to Terraform, where the state has to be saved somewhere like in a Git repository, etc. And it's really like what's special about Crossplane is that yeah, you can, in a way, really provide or abstract away for different personas specific things regarding the configuration, for example, of data services. So let's assume you want to create a database on AWS for your application. There's a lot of stuff to configure usually. And yeah, you have some people that have the expertise to do it, but the developers not. You can, in a way, create those abstractions so that developers only have to define those things that are relevant for them. So like, for example, okay, because they know how much space they need on a database, what's the number, yeah, the gigabyte they want to have for the database. And it's doing that by different building blocks. So the first one is packages that allow more or less to extend Crossplane, to include new functionality, and then they have providers which are actually packages. So the packages include, for example, the Kubernetes controller and all the CRDs you need to manage this stuff. For example, a provider that's yeah, providing all access to all those different AWS services to be provisioned. And then you have, so those providers come with managed resources, which are the Kubernetes native representation of infrastructure components. So like, for example, an RDS service, or if you have, for example, have a Helm provider, which we'll see in a second, this Helm provider will actually yeah, have, for example, a release as a CRD, because that's yeah, how you interact with Helm and install things. Those managed resources, in addition, there is something called composite resources, which in a way provide a way to package several resources to one entity and provide this interface for the users, as already told you, that they don't have to care about specifics and only the things that are, for example, relevant for developers, that they can only define those, and those other things will be provided by people that have the expertise in defining those composite resources. And if we have a look, for example, what's here in the cluster, we can run kubectl get providers. We can see here I currently only have a Helm provider and a Kubernetes provider. With that, I can have all the different custom resources to actually install Helm charts in my cluster, and for Kubernetes to create common Kubernetes resources like a namespace, etc. But they're also providers for AWS, GCP, etc. So all common services that you usually need to, in a way, dynamically provision your databases. The next thing is then those managed resources. And as I said, so those are, for example, the Helm charts. So what I can do is kubectl, have a look because those are real custom resources. CRD releases Helm. So that's really more or less the CRD that defines how a Helm chart actually for then the controller that's running has to be defined, to be applied. In the spec, you can see if you have some expertise in Kubernetes, this is how CRDs look like. So they define the names, etc. And then they have an actual open API specifications on the different configurations you have to actually then create a resource of a Helm release here. If we have a look at the composite resource, at the end it's like, this is called an XRD. So that's more or less the same thing than a custom resource definition, but in the cross-plane world, so they're using the same idea on how to extend cross-plane in this case and not Kubernetes. You can see, so that's just the basic setup. We're using Bitnami Helm charts here. If you don't know that, VMware is also the vendor of Bitnami, or we acquired them. So the biggest open source container catalog. And here we just have a default or basic catalog of services you actually, in most of the cases, need to build your cloud native applications. If we have a look at one of those, so like, for example, the PostgreSQL instance, we can see that it defines, and that's, as I said, that's a higher abstraction here. So some information, but the end, it only defines in that open API specification one parameter. And that's, in this case, the storage of the database. Because all the other stuff, so based on what the operator that created it thinks, is not relevant for the developers, and therefore I don't want to expose it. Which makes it, for sure, a lot easier for the developers to just get, for example, on test clusters, Helm charts with a PostgreSQL database. So that's really the interface. For sure, you have to define, okay, what's actually happening. And if I create such a resource, and for that there's something that is composite, it's also then something created by the operators, which actually shows what's happening here for that Helm chart. And as you know, we have the provider for Helm, and we have the for Kubernetes. And in this definition, it's really like it defines what will be applied as resources. And in this case, you can see, for example, a namespace will be created where then actually this database is running. You can see that the Helm release, so the one that's coming from the Helm provider, will be applied if I have that resource with that specific interface. So it's really a way of defining and abstracting away all the different resources you need for also those providers to provision databases, etc., for the developers that they have an easy interface. And for sure, even if that's Kubernetes native, in best case, you have a UI where then the developer just says, I want to have a PostgreSQL database. Oh, I can only input the storage. And then behind that UI, you, for example, have a GitOps approach where this custom resource will be created, and then everything else is defined in the cluster. And yeah, with that, you will have a really nice interface. And yeah, it's really a separation of concerns, so those people that have the expertise can define all the stuff that's required here. And the Helm chart is for sure something that maybe is more on the test clusters, but it also provides then ways to, in a way, saying, hey, we have that in the CRD, etc. But yeah, on a production cluster, instead of a Helm chart, there will be an AWS RDS database created. Okay, perfect. So now we have that, so we want to give it a try. And if you have a look, you saw that OpenAPI specification, it was just like, okay, PostgreSQL and just the storage. And we can use it as with the custom resources in Kubernetes. You can see it's a PostgreSQL instance. Name the storage, that's the interface we defined, so only thing you have to be defined. And there's one more, so where the secret should be available. For sure, that's also something you would then maybe abstract away for the developers here. And what we can do now is just apply this resource. And yeah, if we have a look, we can see currently we have 3 here, and that's the one we created, and it's already ready. So we can serve it. So the next thing we have to do is, okay, how can we actually... So for sure, we can have a look at the credentials that are automatically generated and put them in our configuration properties, maybe also with the configuration server. So like here. So it takes some time to provision those secrets. Let's see. Hopefully. So it's there, but the secrets are not yet available there. But yeah, and it's like what we need, or the question is, are there better ways to actually get those credentials and attach it to our application? And the answer is yes. And yeah, actually, how we can do that is with the service binding specification for Kubernetes, which is also something we and Red Hat together created. And actually what it does, so the service binding, we also have a reference implementation for that. Those credentials will be, so in the secret, etc., if they have a specific form, they will be attached automatically to the container, so mounted in the pod, and then are available to be, yeah, in a way loaded from the local file system in the container from the application to be consumed. And with Spring, we have a library called Spring Cloud Bindings that automatically, for all common types of data services, that's already implemented for you. So this library, if you add it, it will just see, okay, this is the type PostgreSQL, I know how to set it, and then it will set those configuration options in the properties. So like, for example, for the Redis database, etc. So you don't have to do anything than just adding, for example, the Redis Spring Boot starter, the Spring Cloud binding library, and having a service binding, and then it will attach all those credentials and set them correctly, which is really amazing. And if you're using those Native Buildpacks, for example, with the build image or then with Kpack, that's done. Also, the Spring Cloud binding is automatically attached to your application, so you don't even have to care about this library. And the service binding then looks like this, so it's also a custom resource. As you can see here, it just defines, okay, what's the secret here, and what's the workload I want to bind it to. So in this case, our Knative service, but it could be also a deployment, etc. And if I apply this, I have my service binding. So let's see whether, now I can see I also have those data here. So if I view the secret, I can say, okay, what's the host, for example? you can see the host. And if I now apply the service binding, so it's applied, then I can, in a way, have a look at it. So I, 1 second, because I just attach it to the resource we actually have in the cluster. It's ready, and now we are able to see that we should have another revision coming up. So the third one here, it's just getting started, because this is what the service bind does. It actually manipulates the K service, so the Knative service. And we can see the traffic is already going there. And if I refresh it, so as said before, it was the in-memory database. Without any redeployment, I now have a PostgreSQL database configured in my application. So which is really nice. We don't have to care about credentials or developers with that solution. Okay, so just one more thing I want to mention before we close the session here is that developers need a UI, actually, for self-service, etc. So my recommendation really is, in best case, developers don't have access to Kubernetes. They just need the UIs, the self-service portals, and the observability solutions that they can, in a way, request all the data services they need. They can provide the configuration, the minimal one they need for the applications, and have the tools to see whether the application behaves like it should be, and shouldn't care about containers, Kubernetes, or all the infrastructure. With a real platform experience. And there's a tool to build such a platform portal, so UI, which is called Backstage. It's open sourced by Spotify. They used it for a so-called golden path, where it was like mostly documentation developers went through. At the end, it's like nowadays it's more used in the direction of, okay, it's really to implement a self-service portal, also with a lot of information about the applications that are there, because as you know, nowadays there are a lot of internal APIs that will be just consumed, and having all the documentation in one place, one UI for everything, more or less, which is possible with a huge plugin system also. That's the idea of Backstage, so having one single portal for everything. And as I said, it's really something to build a platform. It's not a portal. It's not a portal itself, so it has some basic functionalities, but you can extend it with plugins. It's in React, so that's another thing maybe for the operators a little bit hard. Because if you want to add stuff there, you have to you need the expertise in React to also maybe build your own plugins. So that's it for today. You saw some of most of the open source solutions here. Some were used underneath, like for example, Carvel. Those are tools from us for templating of YTT. Also contributed to CNCF, and also things like package management on Kubernetes. Contour ingress controller we used. Something I didn't show you today because of the time is Cartographer, which is the new CI/CD system running on Kubernetes from us. And that's it for today. Thank you very much. I hope you enjoyed my session and learned something new.